Section 517.13 of the National Electrical Code requires branch circuits serving patient care areas to have a ground path for fault current. This ground path is typically achieved by installing these circuits in a metal raceway system. However, there is an exception to this rule. Section 517.13b specifically addresses installations in magnetic resonance imaging rooms, commonly known as MRI rooms. In these specialized environments, non-ferrous materials are mandated due to the sensitive nature of the MRI equipment. The presence of ferrous materials, which are magnetic, can interfere with the operation of the MRI machine and compromise the quality of the images produced. Therefore, within MRI rooms, all electrical conductive materials, including raceways, must be non-magnetic. This requirement ensures that the electrical system does not disrupt the magnetic field essential for MRI functionality. Polyvinyl chloride, often referred to as PVC, is a non-magnetic material. Its non-magnetic properties make it suitable for use in MRI rooms. Because PVC does not interact with magnetic fields, it will not interfere with the MRI equipment's operation. Therefore, the National Electrical Code recognizes PVC as an acceptable material for electrical installations within MRI suites. This recognition extends to the use of PVC conduit for housing branch circuits that serve patient care areas within the MRI environment. Even though Section 517.13 generally mandates the use of metal raceways to ensure a robust ground path, the exception for MRI rooms acknowledges the unique requirements of these spaces. The primary goal in MRI rooms is to maintain a non-magnetic environment to prevent interference with the imaging process. To address the specific question of whether a contractor is required to use aluminum conduit in MRI rooms, the answer is no. While aluminum is a non-ferrous metal and can be used in MRI rooms, it is not the only acceptable option. PVC conduit is a suitable alternative that meets the requirements of the National Electrical Code. It is a commonly used material in MRI installations because it effectively isolates electrical conductors while remaining non-magnetic. The use of PVC conduit in MRI rooms demonstrates the importance of considering specific environmental factors when designing and installing electrical systems. While metal raceways are generally preferred for their grounding capabilities, the need to maintain a non-magnetic environment takes precedence in MRI suites. Therefore, PVC conduit is an acceptable and often preferred choice in these settings. In summary, the National Electrical Code provides an exception in Section 517.13b that permits the use of non-ferrous materials, such as PVC, for branch circuits serving patient care areas within MRI rooms. This exception acknowledges the unique requirements of these spaces and ensures the safe and effective operation of MRI equipment. Always consult the latest edition of the National Electrical Code and local amendments for the most accurate and up-to-date information on electrical installation requirements. Remember that local regulations may vary, and it is crucial to comply with all applicable codes and standards. It is essential to consult with qualified electrical engineers and inspectors to ensure compliance with all applicable codes and regulations when designing and installing electrical systems, especially in specialized environments such as MRI rooms. Doing so will help ensure the safety of patients, staff, and equipment. When working on electrical installations in healthcare facilities, one must understand the nuances of Article 517 specifically as it pertains to patient care areas and sensitive equipment environments like MRI suites. The interplay between general requirements, such as the grounding provisions in 517.13 and the exceptions carved out for specialized locations, such as the MRI exception in 517.13b, is paramount for ensuring safety and functionality. The general rule in 517.13 aims to establish a low-impedance ground fault current path. This is typically achieved through the use of metal raceways, which inherently provide a continuous metallic connection back to the source. This low-impedance path is crucial for facilitating the rapid operation of overcurrent protective devices, such as circuit breakers, in the event of a ground fault. By quickly clearing ground faults, the risk of electrical shock to patients and staff is minimized. Metal raceways, such as rigid metal conduit, intermediate metal conduit, and electrical metallic tubing, are commonly used for this purpose. However, in MRI suites, the introduction of ferrous metals can significantly disrupt the homogeneity of the magnetic field, leading to artifacts in the MRI images and potentially compromising diagnostic accuracy. Therefore, the exception in 517.13b recognizes the need to use non-ferrous materials within the MRI room itself. This exception allows for the use of non-metallic raceways, such as PVC conduit, for the branch circuits serving patient care areas within the MRI suite. PVC conduit is a suitable alternative because it is non-magnetic and does not interfere with the MRI equipment. It is essential to note that the exception in 517.13b is specifically for installations within the MRI room. Outside the MRI room, the general requirements of 517.13 still apply, and metal raceways should be used for branch circuits serving patient care areas. It is also crucial to ensure that the grounding system within the MRI room is properly designed and installed to minimize the risk of electrical interference and ensure patient safety. This may involve the use of isolated ground receptacles and dedicated grounding conductors. When using PVC conduit in MRI rooms, it is essential to follow the manufacturer's instructions for installation and support. PVC conduit must be properly supported to prevent sagging and damage. The support should be spaced according to the manufacturer's recommendations and should be made of non-ferrous materials. It is also crucial to ensure that the PVC conduit is properly sealed to prevent the ingress of moisture and contaminants. The fittings used to connect the PVC conduit should also be non-ferrous and should be listed for use with PVC conduit. In addition to the raceway requirements, it is also essential to consider the wiring methods used within the MRI room. All wiring should be installed in accordance with the National Electrical Code and should be suitable for the environment. The wiring should be properly insulated and protected from physical damage. It is also crucial to ensure that the wiring is properly grounded to minimize the risk of electrical shock. When selecting electrical equipment for use in MRI rooms, it is essential to choose equipment that is specifically designed for use in these environments. This equipment should be non-magnetic and should be designed to minimize the risk of electrical interference. It is also crucial to ensure that the equipment is properly grounded and that all connections are tight and secure. Regular inspections and maintenance of the electrical system in MRI rooms are essential to ensure its continued safety and reliability. These inspections should be performed by qualified personnel and should include a thorough examination of all wiring, raceways, and equipment. Any deficiencies should be corrected promptly to prevent potential hazards. In summary, the electrical installation in MRI rooms requires careful consideration of the unique requirements of these environments. The exception in 517.13b of the National Electrical Code allows for the use of non-ferrous materials such as PVC conduit for branch circuits serving patient care areas within the MRI suite. However, it is essential to follow all applicable codes and standards and to consult with qualified professionals to ensure that the electrical system is properly designed, installed, and maintained. This careful approach will help ensure the safety of patients, staff, and equipment and will contribute to the accurate and reliable operation of the MRI equipment. Remember to always prioritize safety and to consult with qualified professionals when working on electrical installations in healthcare facilities. The potential risks associated with electrical hazards in these environments are significant, and it is essential to take all necessary precautions to mitigate those risks. By following the guidelines and recommendations outlined in the National Electrical Code and other relevant standards, it is possible to create safe and effective electrical systems in MRI rooms and other healthcare facilities. The importance of grounding cannot be overstated. Grounding ensures that any fault current has a safe, low impedance path back to the source, allowing overcurrent protection devices to trip and energize the circuit quickly. In patient care areas, this is especially critical as it minimizes the risk of electrical shock to vulnerable patients. The NEC provides detailed requirements for grounding and bonding in Article 250. Proper grounding involves connecting all non-current carrying metal parts of the electrical system to ground, including enclosures, raceways, and equipment frames. This creates a continuous, low-impedance path for fault current. Bonding is the process of connecting different metal parts together to ensure that they are at the same electrical potential. This minimizes the risk of voltage differences that could create a shock hazard. In MRI suites, the grounding and bonding system must be carefully designed to minimize the risk of electrical interference with the MRI equipment. This may involve the use of isolated ground receptacles and dedicated grounding conductors. The isolated ground receptacles provide a separate grounding path for sensitive electronic equipment, preventing noise and interference from other equipment in the same circuit. The dedicated grounding conductors provide a low-impedance path for fault current, ensuring that overcurrent protection devices trip quickly in the event of a ground fault. The selection of wiring methods is another important consideration in MRI suites. The NEC provides a variety of wiring methods that are suitable for use in healthcare facilities, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. However, in MRI suites, the use of ferrous metal raceways is generally prohibited due to the potential for interference with the MRI equipment. Non-ferrous metal raceways, such as aluminum conduit, can be used, but PVC conduit is often the preferred choice due to its non-magnetic properties and the ease of installation. When using PVC conduit, it is essential to follow the manufacturer's instructions for installation and support. PVC conduit must be properly supported to prevent sagging and damage. The support should be spaced according to the manufacturer's recommendations and should be made of non-ferrous materials. It is also crucial to ensure that the PVC conduit is properly sealed to prevent the ingress of moisture and contaminants. The fittings used to connect the PVC conduit should also be non-ferrous and should be listed for use with PVC conduit. The selection of electrical equipment for use in MRI suites is also critical. All electrical equipment used in MRI suites must be non-magnetic and must be designed to minimize the risk of electrical interference. This includes lighting fixtures, receptacles, switches, and other electrical devices. Non-magnetic lighting fixtures are available with special shielding to prevent electromagnetic interference. Non-magnetic receptacles and switches are also available with special contacts and housings to minimize the risk of electrical noise. It is also essential to ensure that all electrical equipment used in MRI suites is properly grounded. Regular inspections and maintenance of the electrical system in MRI suites are essential to ensure its continued safety and reliability. These inspections should be performed by qualified personnel and should include a thorough examination of all wiring, raceways, and equipment. Any deficiencies should be corrected promptly to prevent potential hazards. The electrical system in MRI suites should also be tested regularly to ensure that it is functioning properly. This testing should include ground impedance testing, insulation resistance testing, and other tests as required by the NEC. The results of these tests should be documented and maintained for future reference. In addition to the requirements of the NEC, there may also be local codes and regulations that apply to electrical installations in MRI suites. It is essential to consult with local authorities to ensure that all applicable codes and regulations are followed. The electrical installation in MRI suites is a complex and critical task that requires careful planning, design, and installation. By following the guidelines and recommendations outlined in the NEC and other relevant standards, it is possible to create safe and effective electrical systems in MRI suites.